In section 7.2, I want you to be able to graph and recognize inverses of relations and functions and find inverses. So let's just talk about inverses. We'll go back to section 1.2, where you identified additive and multiplicative inverses of given numbers. And hopefully you remember the additive and multiplicative inverses. When you have the number negative 2/3, the additive inverse is just the number that you add to it to get 0. And the multiplicative inverse is just the number that you multiply to get 1. So here, when we do the multiplicative inverse, we flip the number or take the reciprocal. Now in section 7.2, you're going to apply inverses to relations and functions. And I just want to remind you of what a relation and a function is. A relation is a set of ordered pairs. And a function is a relation, so a function is a set of ordered pairs in which every input value, or x, is paired with exactly one output value, which is y. Now, when we talked about functions before, we said x's do not repeat. It's okay for the y's to repeat, but in a function, the x's cannot repeat. To find the inverse of a relation, it's very easy. You just switch the x and y values of each ordered pair. So I have an example here for you, and I'd like you to graph the relation, and when you graph it, connect the points. So go ahead and graph that. All right, now all you need to do for the inverse is simply switch the x and y. So you're going to switch the 0 and the 6, switch the 2 and the 10, and then you'll have the inverse of the relation. Okay, so what that looks like is just all of the y's become x's, and all of the x's become y's, and that's all you have to do. So don't make it any more difficult than what it is. Now I would like you to graph the relation and connect the points, and then also graph the inverse and connect the points. Now, when you graph a relation and the inverse, you want to graph the line y equals x. This is the line y equals x. And if you have successfully graphed the relation and the inverse, you can kind of just picture this in your mind. If you would fold your graph on this line right here, you could hold that up to the light and there would be no overlap after the paper is folded. All right, now we talked about domain and range at the beginning of the year, and we've talked about domain and range throughout the year. And the domain would be the x values, the range are the y values. So when we talk about the domain of the relation, the smallest value that we have on the relation here is 0, the largest value is 10. So we have the set of all values x such that x is less than or equal to 10, but it's greater than or equal to 0. And then here is the notation for your range. We have all the values in between and including 6 and 13. All right, since we switched the x's and the y's from the relation to get the inverse, it makes sense that the domain and the range are going to be switched. What was the domain with the relation now becomes the range of the inverse. So basically, when we write this out, the domain of the relation becomes the range of the inverse. And the range of the inverse becomes, the range of the relation becomes the inverse. I just said that wrong. The range of the relation becomes the domain of the inverse. Now remember that inverse operations also undo each other. Addition undoes subtraction, and multiplication undoes division. When the relation is also a function, you can write the inverse of the function as, and this is f, and we have like a exponent. It kind of looks like it's not really an exponent, but it looks like an exponent of -1. And this is read f inverse of x. So it looks like a -1 as an exponent, but it represents an inverse. All right, writing an inverse function is very easy to do. If we start with a function, here's our function right here. The first step that we're going to do is switch the x and the y, and only the x and the y. So I've put a box around the x and a box around the y, and we're going to solve for y. So the first thing, well, first we need to switch here. So we're going to switch the x and the y, so it looks like this. And now we're just going to solve for y. So we want to get y by itself. In order to do that, we need to add 5 to each side. And that's going to leave us with x plus 5 equals 8y. And then just divide both sides by 8. All right, now we need to show that we have an inverse instead of the original function. Notation in math is very important. So this represents the original function, f of x. And to show the inverse function, we're going to do f of x, and this means f inverse. When we put this right here, that's the inverse of the original function. And it's going to be x plus 5, all of that divided by 8. Okay, on the other side, we are going to, first I want to talk about the line y equals x, because that's the line that you fold. You can think of folding your graph, and the relation and the inverse, or the function and its inverse, should lie right on top of each other. So inverse functions reflect over the line y equals x, and that was already graphed on the other side for you, and we labeled it as y equals x. But for some reason, students sometimes have a problem with the line y equals x, and I think it's because they don't see a slope there and they don't see a y-intercept, and they just see y equals x. So all that means is when x equals 1, y equals 1, x equals 2, y equals 2, and vice versa. The slope here is going to be 1, and the y-intercept is, this would just be like plus 0 here. So the y-intercept is 0. So if you need to graph this line, then it's, if x is -1, y is -1. So it's 0, 0, 1, 1, 2, 2, and so on. You could keep going. So when graphing a function and its inverse, always draw the line of reflection as a dashed line. Okay, so we're going to have a function here. I'm going to have you find the inverse, and then we're going to graph the function and the inverse, so you can see just like we did on the other side with a relation. Okay, so here is the function. I'm going to have you go ahead and find the inverse. Okay, as you're finding the inverse, remember you switch the x and the y. So we've switched x and y here, and then we've switched the f of x to y, and now we're going to switch the x and the y. So the x comes over here, the y goes here. That's all you switch. Don't switch any of the numbers, only x and y, and then you solve for y. So we need to subtract 2 from both sides. And when we subtract 2, we're going to get x minus 2 equals 2/3 y, and we still need y by itself, so we're going to multiply by the inverse, which would be 3/2 on both sides, and then you're going to end up with 3/2 x minus 3 equals y, and if you use the notation f inverse of x, because f of x is our original function, f inverse of x is the inverse function. All right, now we're going to graph both of those. Okay, so graph both of those functions and also draw the line of reflection in. Okay, once you've graphed those functions, I graphed the original function in green here. The pink is the line of reflection, and the blue is the inverse function. So again, if we took this paper and we folded it in half, this line would be right on top of that line, and that's how you know that you've correctly found and graphed your inverse of the original function. All right, there are a few questions for you to try.